Hey guys, and welcome back to another video. In this video, we will be discussing 1.7 polynomial functions and complex zeros. Alright, so to begin with, let's just discuss the fundamental theorem of algebra and what it's saying. So basically, what the fundamental theorem of algebra says is let's say you have some polynomial function. If you have some polynomial function, let's call it p of x, and with degree n, then and let's say it has zeros like r1 through rn, and it has zeros r1 through rn, then what the fundamental theorem of algebra says is that we can factor the polynomial p of x as x minus r1 all the way up until x minus rn, right? So in total, we'll have a total of n factors since the degree is n. And since we have n linear factors, that means that our polynomial p of x has exactly n distinct, or not necessarily distinct, but n zeros. And so that's basically what it's saying. So it's basically like if you have some polynomial function p of x with degree n, then it must have exactly n zeros, right? And important note is that these zeros are in the complex numbers. So they could be, all these zeros are complex, they could be real or complex, right? But they all have the form a plus bi, right? Okay, but that's pretty much what the fundamental theorem of algebra is saying. So let's illustrate this with some examples. So for example, let's start off with a pretty easy one. So example 1, let's see how some polynomial function p of x and it's equal to x squared minus 4, right? So hopefully we already know how to factor this, right? This is just the difference of squares formula. So we could just factor this as x minus 2 times x plus 2, right? But the key thing to realize is that our degree of the polynomial is 2, and we also have 2 linear factors. And that's pretty much the big idea in this lesson. And so the two zeros of this polynomial would be plus minus 2, right? Let's move on to a little bit more challenging problem. Let's say if we have p of x equals x to the 4th minus 16. So again, this is also just the difference of squares. You would get x squared minus 4 times x squared plus 4. But the fundamental theorem of algebra guarantees that p of x should have 4 distinct linear factors since the degree is 4. So that means we could factor this further, and indeed we can, because x squared minus 4 factors as x minus 2 times x plus 2, and then x squared plus 4 actually factors as x plus 2i times x minus 2i. And that's the sum of squares formula. So a little note to the side, just so you guys know what I'm talking about. If you have, let's say, a squared plus b squared, this is going to factor as a plus bi times a minus bi, right? That is how it will always factor. Okay, good. But now notice how we have degree 4 polynomial and has 4 linear factors, and all the zeros are within the complex world. So x is equal to plus minus 2 or plus minus 2i, right? They all are within the complex plane, complex world. All right, good. So now let's actually turn our attention back to this note that I put over here. Notice how if we do have some like complex solution or root, then notice how it always comes as itself with a conjugate pair. And so that's the next important thing that you need to know is that if there's ever a complex zero present in a polynomial, then it has to come with its complex pair. So for example, if we have like some polynomial function p of x is equal to x to the fourth minus x cubed minus 5x squared minus x minus 6, and we're given that I is a 0, right? So we're given that I is a 0. So we know that if I is a 0, then negative I must also be a 0. And from the fundamental theorem of algebra, since this is a fourth degree polynomial, we know that this should have 4 linear factors. So generally speaking, this should factor as x minus r1 times x minus r2 times x minus r3 times x minus r4, because we have 4 linear factors. But we already know 2 of the factors, because one of them is I, and since that's a complex root, that we know that another factor has to be negative I. So we can plug that in, so we get x minus I, and then x plus I, and then you have x minus r3, x minus r4. And now it's just a matter of finding these 2 factors. And we can do that by simply dividing the original polynomial by this. So if we expand out this, right, this is just reversing the sum of squares formula. So if we have some 2 factors, a plus bi, a minus bi multiplied together, it just becomes a squared plus b squared. So this would just become x squared plus I squared, which I squared is, or it should be x squared minus I squared, which I squared is negative 1. And so you get x squared plus 1 here, and then you have x minus r3, x minus r4, right? And p of x is just equal to that. So if you just divide both sides by x squared plus 1, we can find what this product is equal to over here. So now we can do like long division, polynomial long division. So we have x to the fourth minus x cubed minus 5x squared minus x minus 6 divided by x squared plus 1. I'm going to write it as x squared plus 0x plus 1. Okay, good. So now basically we know that this polynomial becomes x squared plus 1 times x squared minus x minus 6. But from this, we know that this has to factor into 2 separate factors. And indeed it does. So we can factor that even further. So we get x squared plus 1, and that factors as x minus 5 times x. Actually, sorry, x minus 6 times x plus 1. Is that right? Hold on. Sorry, my bad. It should factor as x minus 3 times x plus 2. Yeah, okay, that's how it factors. But that is the factorization of this polynomial. And that's going to be like the main goal in most of these problems, is just like trying to factor the polynomial, either given a 0 or not given a 0, as we'll see in the next example. But yeah, you could just kind of use the fundamental theorem of algebra, which says that if you have an n degree polynomial, in this case, 4th degree, it has to have n terms. So in this case, 4 linear factors. All right, let's move on to the next example. And in this one, we're not given any zeros, right? We're just given a polynomial, and we have to factor it. I'll just get rid of this too. Okay, so let's see. So let's say you have a polynomial p of x is equal to 5x to the fourth plus 2x cubed minus x plus 2. And that's all you're given, right? You're not given any zeros in this case. So how would you go about approaching this one? So first, you just want to see how many possible real and or complex zeros does this polynomial have. So we'll just split this up into like the real numbers and the complex numbers, right? So a neat trick is we know that complex numbers have to come in pairs, right? Conjugate pairs. So the number of complex zeros has to be even, right? And the total number of zeros has to add up to the degree because nth degree polynomial has n terms, or n zeros, right? That's the fundamental theorem of algebra. So we can either have 0, 2, or 4 complex or imaginary zeros. And then the corresponding real zero just have to add up to the total degrees, in this case 4. So that means that if you have 0 complex zeros, you have to have 4 real zeros. If you have 2 complex zeros, you have to have 2 real zeros. And if you have 4 complex zeros, you have 0 real zeros, right? Because adding these across, you should get 4 each time, right? And then now we can break down the real zeros even further into negative real zeros and positive real zeros using Descartes' rule of signs. And I'll just tell you that the number of positive real zeros is either 2 or 0, and negative real zeros is also 2 or 0. And remember, the way you do that is to find the positive real zeros, you see the number of sign changes in just p of x. So we have 1 and then 2 sign changes, so that's why it's 2 or 0. And then to find the number of negative real zeros, you take p of minus x, find that polynomial, and then find the number of sign changes in that one. And it is 2 or 0. Okay. So then we could break this table down even further. So we have positive reals, and then we have negative reals, and then we just have complex. So complex is going to stay the same, right? That's not changing. That's still 0, 2, or 4. But the positive negative reals, you have to split them up, right? So if we have 0 complex zeros, we have to have 4 total real positive and negative. So that means we can have 2 and 2, right? That's the only way for that to work out. And then I'm actually going to I'm gonna fill this in as I go because like there's multiple different scenarios. So let's just start off with like the possibility that there's 2 positive zeros, right? 2, 2. So then if there's 2 positive zeros, then there could be either 2 negative real zeros, which results in 0 complex zeros, or there could be 0, which results in 2, right? Because it has to add up to 2. And then there's the possibility that there's 0 complex zeros or 0 positive real zeros, my bad. And that means that there's either 2 negatives or 0 negatives. So in the case there's 2 negatives and 0 positives, there has to be 2 complex. And in the case there's 0 reals, like positive or negative, there has to be 4 complex. And so this is kind of like your chart. So these are like the different possibilities. So you can have 2 positive, 2 negative, 0 complex, 2 positive, 0 negative, 2 complex, 0 positive, 2 negative, 2 complex, or no reals and then just 4 complex, right? And then from here you would just like go about factoring this as we did in like previous sessions, like lectures. So you just like do like the number of positive, like you already did the number of positive negative roots, and then you just like see like the rational root test, that's the word, the rational root tests, like p over q, and just do all that. But for the sake of this video, I'm not going to go into all that. But yeah, that's how you go about it. So essentially, you just want to like, if you're not given a 0, then you want to like make a table of the positive and negative reals and then complex zeros using Descartes' rule of signs and the fundamental theorem of algebra. But if you are given a 0, then you can use the fact that so if you're given an imaginary 0, then you know that the conjugate of that also has to be a 0. And if you're given a real 0, then you could just put that into like the formula. So like for example, the formula was like when you had the x minus r1, x minus r2, all the way up to like x minus r4, right? So the number of terms depends on the degree, but you just put that in and just like kind of do long division to find like the rest and just factor it right for from there. But yeah, other than that, that's pretty much it for this lection. It's relatively easy. Yeah. Make sure to like and subscribe, and don't forget to follow. See you in the next video.